solution which, yes, so about last time I found that the problem, I found like an alternative solution, like using similar triangles.
Yeah. One second, let me just draw the diagram if I recall, so that everyone is on the same page. I just want to share screen, make sure recording is on.
So in the last class, the last sum, can you explain how you like simplified the squares and like took out the solution?
Yeah, sure, definitely. Just 1 second, Manya. Let me just draw the picture if memory serves me well. So it is a triangle. Sorry.
So should I just put the copy again?
Yeah, if you have, you can just put it here.
Yes, yes.
Or it's fine. I can just draw it. Just tell me the dimensions. It's fine. I remember a triangle like this. This was 17, was it? Or was this given to be 7? This side was given to be 17, was it?
Yes. This side was 17.
This 17, and this base was given to be 16 or
Yes.
something, right?
Yes.
8 and 8. And then there was a circle here. So I'll just draw a circle here. There was a circle here, right?
So a semicircle.
You sent the picture on the group? Is that what you said?
So it was a semicircle.
Semicircle? Okay, I see. Where was the semicircle? It was the base was touching, right?
Yes, so like
The base was touching. Okay, all right. So it was something like this.
So I'm just putting up the picture in the chat again.
Yeah, put it on the group chat itself. And then this was something like,
no, so it was like it was coming from the base, like
oh, I see. I forgot the picture. Okay.
So it's on the group chat as well.
It's on the group chat. Yeah, I'll be able to paste it. Okay, wonderful. Okay, I'll just copy paste this diagram then. Here. Just 1 second now. Okay, all right. This is the picture. I can erase this. And what is the question? You should find the radius of the semicircle, correct?
Yes.
Radius of the semicircle. And this was given to be 17. Maybe I should make it slightly smaller. It's too big.
No, sir, the size is fine.
No, sometimes the clarity goes down. Okay, all right. So this is 17. And this is 17. And this was 8 and 8, correct? This was 8 and 8. Okay, so before I take the alternative way, Prashast, Vanya, what was your problem? I didn't fully understand your problem, Vanya. What was that? So first, let me just recap what we did. I think maybe I did some other way. I don't remember how I did it. Okay, so we connect this here, right? Something like this.
Yes.
And then we can say, first of all, we know that 17, 8, and 15 are Pythagorean triplets. Vanya, what was your question? Can you repeat your question, Vanya?
So in the in the question, we had found out that r square is equal to 8 square minus 64 by 17 whole square. And somehow you had simplified it. I did not understand.
Okay, all right. Let's go through that again. Okay, so this is, so let's call this A, B, C. Okay, so first of all, we know that 8, 15, 17 is a triplet. So we know this is 15. And this radius is R. This is what we are trying to solve, correct? Okay, and let's say this I keep as X. And therefore, this portion is 17 minus X, still here. Till here, it's 17 minus X. You with me so far? Now, maybe I labeled things a little differently then. Doesn't matter. Let's say this is the picture right now, right? So there are two right-angle triangles here. Because, Vanya, are you following along so far?
Yes, sir.
So in the first right-angle triangle, X square plus R square equal to 8 square. Okay. In the second right-angle triangle, right? So the first right-angle triangle I'm talking about is, let's say, EDC, in the EDC triangle. Okay. In the other right-angle triangle, which is ADE. In ADE, then I have 17 minus X whole square plus R square equal to 15 square. Yeah. Vanya, you're with me, right, so far?
Yeah.
And now I can expand both of them and I can just subtract, right? So 17 minus x whole square plus r square, x square plus r square equal to 8 square. Okay. If I'm doing some mistake, please call it out soon rather than wait. Okay. So if I expand the second one, what does it become? It's 289 minus 34x plus x square plus r square equal to 15 square. Yeah. The second equation, I'm expanding a minus b whole square. Vanya, I need you to nod along. You're okay, right, so far? You're on mute, Vanya, if you're saying something. She's frozen. Okay, so now this portion we know is from this equation, we know it's 8 square. Therefore, we have 289, okay, minus 34x plus 64 equal to, maybe I did it in a different way. So this is 225 right now, right? Am I right? Okay, now this can be simplified further. So this is, if I bring the 34x to this side, and then the 225 to this side, it becomes 128, right? This, I know it's 128 because 229 minus 25 is 64. 64 plus another 64 is 128. Therefore, x is 128 by 34, which is 64 by 17, right? So far so good. Vanya, you're okay so far? You're on
Yes,
mute.
so after
Okay.
understand.
Okay, after this, now we can substitute this in this first equation and solve for x, right? So I have solve for r, sorry. So 64 by 17 whole square, which is my x square, plus r square equal to 8 square. Okay, so I just have to first we have drawn a reasonable, let's do a simple sense check. 64 by 17 is how much approximately, Akshar? What is 64 by 17 approximately?
Sir, approximately 3 point something.
3 point something, right? Or rather close to 4. 17 times 4 is 68. So closer to 4. And does this diagram look something like that? Yes, it does look close to 4 because it's been drawn reasonably to scale because the question is given to us. This looks like 8. Half of 8 is approximately 4. This looks like approximately. So always do some basics. The reason I'm saying is, मान लो अगर कुछ गलती हुआ इधर. Let's say you made some mistake and instead of 64 by 17, you wrote it as 164 by 17, something, which is approximately 10, right? That doesn't make sense at all, right? How can x be 10 when this lower portion itself is 8, right? So do some basic sense check like that based on the size. Okay, now r square, therefore, so what I'm saying here is, don't do all these big squares, try to simplify. So how am I simplifying? This is 8 square minus 64 square by 17 square. Yeah, so now between, I can write this as 8 square minus 8 square into 8 square. Yeah, I'm doing this for you by 7, or even others also. So you're okay with so far? I can take 1 8 square outside and write it as 1 minus 8 square by 17 square. Now, the reason I do that is because I know my 17 square minus 8 square is my 15 square.
Yes, so that is what I got confused. How is 17 square like minus 15?
Is something wrong in this?
Square, 15 square.
Because I know 8, 15, 17 is a triplet.
Oh, okay, sir.
That's why. And therefore, r just becomes the square root of this, which is 8 into 15 by 17. Sorry, Arsh, you were saying, what is wrong about this?
Oh, I thought that between 8 square, dot 8 square, I thought it to be a minus sign. It's okay. It's a multiplication sign.
This is the multiplication sign. Yeah. Okay. Yeah, Sukrit, I got your message saying your video is off. I mean, some issue with the system, right? Are you there, Sukrit? Okay. All right. You dialed in through.
Sir,
Yes. Yes, Sukrit.
I'll join from a new device in a few minutes.
Yeah. But stay on here.
Yeah, until I join.
Yeah. So that you're not losing content. Okay. Now back to Prashast. So Prashast, you wanted to do using similarity of triangles. Yes. Go ahead, please, Prashast.
Yes, so basically what I did was, that first I noticed that angle C is equal to angle B because it's an isosceles triangle.
Yeah.
And because like of the perpendicular angle BEA is equal to angle
Yeah.
EDC.
Okay. Yeah. The two triangles are similar. Yes. Go on after that. After that.
Now that we've established using a similarity, we know that the two triangles are similar.
Correct.
Since they are similar, that must mean the ratio of their sides is equal.
Yes.
So let's look for the
Yes.
pattern.
Understood.
So
Understood.
what
Yeah.
I did was I did some pattern hunting. So in the small triangle, the hypotenuse is 8.
Yeah.
And in the big triangle, the hypotenuse, yes, the hypotenuse is 17.
Correct.
Now, 17 or 8, like what do you divide 17 by to get 8? So you divide 17 by 8, 17 by 8 simplify ho gaya as a fraction. Okay? So 17 divided by 17 by 8 is equal to 8. Correct?
Yeah.
Therefore,
I understood completely what you did. That's excellent. Okay, I'll just explain to class what he did. Well done, Prashant. Okay, but yes, similarity of triangles is another way to do it. And in fact, that's very good because you can save a lot of these calculations as well. So what he's trying to say, actually, even before we come to this problem, in general, there's a very good similarity concept that we should go through. If I have any right angle triangle, right? So first of all, let's see. Where is Arsh? Arsh was there, right? Arsh, what are similar triangles? What do you mean by similar triangles?
When they're congruent, like if
Then
you
why do we need two different terms? Is congruency and similarity same, Arsh?
no, sir.
Okay, then what is the difference?
They're the same type of triangles like isosceles, scalene, or
Okay, Arjun, what is the difference between similarity versus congruency?
The similarity is like the triangles are not exactly the same, but they have similar properties, like their side lengths are in equal proportion, the angles are equal proportion. But congruence is that the triangles are exactly the same.
Yeah, you're partially right. I know you didn't mean to say this. You didn't mean angles are in proportion. You meant sides are in proportion, right, Arjun? Yeah, angles will be same. So similar. Okay, very simply, Arsh. Similarity means same shape, but size need not be same, right? You say, right, like oh, this kid looks similar to his dad. Means what? He's not the same size, but the shape, features, everything is similar, right? So similarity means the shape will be same, but the size difference could be there. That's what similarity is. Whereas congruency is, think of them as twins, right? So exactly same shape and same size. Right, so congruency would mean similarity also because it's a stronger condition, not merely the shape, but also the size is same. Those are congruent. Does it make sense? So for congruency only, you would have studied all of these properties, right? SAS. Have you done all these? SAS, SSS, and all. Okay, so all of them.
Yes, sir. SAS, AAS, ASA, SSS, and RHS.
RHS. Yeah, RHS is for in a right angle triangle. Yes.
Yes.
And then ASA is same as AAS as well, right? ASA.
No, AAS is same as ASA, right? Not ASA is same as ASA.
No, ASA and AAS are effectively the same. Why do you think that is the case, Sukrit?
What?
I'm asking Sukrit.
Oh, okay.
Sukrit, there's an AAS property and ASA property of proving congruency. Why are both effectively the same? Why do you think?
Sir, we haven't done congruency of triangles yet.
You have not done congruency of triangles yet. Okay, Akshar, what about you?
Sir, I think they are similar because it requires two angles to be same and one side to be same.
Okay, but then what is the difference between ASA versus AAS then? Why do we list them out as two different ways of congruency?
So I'm not sure.
Okay, Vanya.
So in AAS, like two consecutive two adjacent angles are equal, and in ASA, like opposite angles, they are like separated by.
But what do you mean by adjacent angle? This angle and this angle, let's say there are three angles, all of them are adjacent to each other. Yeah. Okay, Precious. What is the difference between AAS and ASA? Precious.
So there is kind of a difference. There is also kind of not a difference. So basically, what happens is, so can you just like draw a triangle?
Okay, yeah, ABC.
Like literally any triangle will work. Yeah. Now AAS would be angles because in ASA the side is sandwiched between. So it's an including side. But in AAS nothing is being included. But they are effectively the same because they use the same method, kind of. So like if we prove that AB is equal to something else and BC is equal to something else of another triangle correspondingly. And we also prove that C is equal to something else of another triangle correspondingly. Now we know that it must be similar as well, not number one, because it will be congruent. Number two, because if two angles of a triangle are same, then the third will automatically become same by the triangle interior angle some property. Then once we find the third angle, the side will become included. Then it turns into ASA.
Correct. Exactly.
Then,
exactly. Yes. Yeah. Well answered there. Okay. So just for starters, right? So Sukrit, when you say SSS, these are all tests for congruency. So to prove two triangles are congruent, okay. So to prove two triangles are congruent. For example, I have this blue triangle, and let's say I have another red triangle here, right? So I'll just draw another red triangle. So okay, so these two triangles are actually congruent looking, right? By congruent, what do I mean? So for example, let's say I label this as A, B, and C, okay? And this other one, let's say I label it as P, Q, and R, okay? Now, if I tell you, okay, let's assume it's not a right angle triangle. Let's assume it's a normal triangle. I'm not saying, let's say it's 89 degree or something. Don't assume it's right angle. Okay, so let's say I tell you that PQ, the side PQ matches with the side AC, the side QR matches with the side BC, and the side PR matches with AB. That means you're telling three sides in this triangle match with three sides in the other triangle. If you're giving that information, that means effectively you're saying the two triangles are congruent. Is that clear, Sukrit?
Yes, sir.
Okay, so that's one way of proving congruency. The other way, so that's the first way. Now, sorry, that's this one, right? SSS. Now, if you look at SAS, the reason the A is put between the two sides is the angle is sandwiched between the two sides. So let's say in the information given, I'm not saying PQ is given to be equal to AB. Let's say that is nothing is mentioned about it. But let's say, okay, fine. I'll just erase this portion. Okay, so let's say QR is being given equal to BC and PR is being given to equal to AC, right? And let's say this angle is given to be equal to this angle. Angle C is given to be equal to angle R. So let me repeat again what I'm said. So QR is given to be equal to BC and PR is given to be equal to AC. And then angle R is given to be equal to angle C. So if this is the case, the angle is included between the two sides. So this is one side, this is one side, and this is an angle which is included between the two sides. Similarly, here there are two corresponding sides and an angle which is included. So if this matches between two triangles, then also the two triangles are congruent. That's the SAS property. So likewise, ASA would mean two angles and an included side. Does it make sense? Akshar, you're with me. Panya, you're with me.
Sir, so if the angles given are, let's say angle Q is equal to angle B and angle C is equal to angle R,
Yeah.
Then which side will they say? PQ is equal to CA or PR
No.
is equal to
Okay. So I'll draw a fresh diagram here. So let's say, in fact, I don't want to draw it like a right angle triangle so that people don't. Okay, and I label them M, N, P, and then X, Y, Z. Okay, so if angle M is given to be equal to angle X, MN is given to be equal to XY, and MP is given to be equal to XZ. So that was the SAS, correct? That we agreed. Exactly same way. Now just imagine the rules between the angles and sides are reversed. Angle M is given to be angle X and angle P. Sorry, M and X are same, P and Z are same, and the included side, which is MP, is given to be equal to XZ. Then it's called the ASA property. Angle, side, and angle. Does it make sense, Sukrit? Okay. On the other hand, back to what Sukrit Precious was telling, right? So if this angle is given to be equal to this, and this angle is, okay, the two angles are given, but the non-included side is given. Let's say this side, right? So this side is given to be equal to length to PN. Then it is angle, and the side which is not included between the two angles, right? Then also it's a congruency property. And the reason for that is this is effectively equivalent to saying it's ASA. Why? Because if these two angles are equal, automatically the third angle will also be equal, because the three angles in a triangle add up to 180 anyway. And therefore, this now becomes like a ASA, because two angles and an included side. This is A, this is another A, and this becomes an included side. So if two angles are given, automatically the third angle is also given. And therefore, it becomes like AASA, you can say. Angle, there's a side in between, and then the third angle is inferred. And therefore, you can either use this property or use this property.
So how did NP and YZ become equal? Like through what congruency did you derive that?
No. Suppose I gave that information that NP and YZ are equal. Okay, so, right? So I gave angle M and angle N are equal. Okay, so let's see whether I can erase multiple steps here. Okay, let's back to this picture, Arsh. Right? Now, you agree that this is AAS as it stands. The two angles are given equal. Okay, so maybe I should mark this with double. This is with double. Okay, do you agree this is AAS, Arsh?
Yes, sir.
But what Precious is telling is that this is also equivalent to ASA. And the reason is because the third angle becomes
angles is 180.
Yes.
Exactly.
Angle is also
so this angle becomes, so effectively this reduces to ASA. Okay, so these are all congruencies. There's one other congruency, which is RHS. RHS is, R stands for right. Okay, in other words, it's a right angle triangle. And H stands for hypotenuse. And S stands for side. Okay, so let's draw two right angle triangles to understand this. So I'll just draw two right angle triangles. So this is one right angle triangle here. And then suppose I draw another right angle triangle here. Okay, and suppose both, first of all, first information that's given is the right angle, which means this angle is given to be, this is given to be equal to 90. This is also given to be 90. That's a right. Second information that's given, because this right angle triangle, there's a hypotenuse. This hypotenuse is matching with this hypotenuse. And the third information that's given is any one side of the remaining side. So I'd say this side is equal to this side. Then these two triangles are congruent. Okay, now this is true in a right angle triangle. But let's say we have some other triangle which is not right, but a very similar picture. Let me draw another one. So this is given, this is given, this is given. Okay, and again, I'll draw another one, which is, okay. Now, again, let me repeat. So let's say this angle is given to be this angle. Instead of 90, just imagine this is 80 degree now. Okay, there's no hypotenuse, but let's say this is the opposite side to this big angle. This is the opposite side to this big angle. And then the other side, which is this, but not included between, not the angle is not sandwiched between the two, then this becomes angle, side, and side. The angle that's given is not sandwiched between the two sides. Correct? Sukrit, are you with me?
Yes, sir.
Yes.
Now,
Is this congruent?
this is not congruent. That's the point I want to say. So this is not, this cannot be used for congruency.
Okay, sir.
Okay, so ASS is what? Ass is what? Donkey. So donkey cannot be used for congruency. Cannot be used for congruency. Okay. Now, why is this?
Sir, can I explain?
Yeah, just 1 second, Precious, before we go for why is this. This also seems like ASS, right? So the one that we draw here, that we drew here, this is also ASS. The only thing is this angle happened to be a right angle, which is why we gave it special attention called R. Okay. Other than that, here also there's a side, here also there's a side. This side therefore became a special name called hypotenuse. But otherwise in concept is very similar. There's an angle here, there's an angle here. It happens to be 90 in one, in 80 in the other case. And because it's 90, the side has a special name called hypotenuse. In the other case, does not have a special name. It's just a simple side. And there's some other third side, which is given to be equal to Tamil side, the third side. Sorry, some other third side. Then why is that the congruency does not work in the normal 80-degree Vela triangle, but the special 90-degree triangle, it works? Yes, Prashant. Can you tell me why it works? Actually, Prashant, you've been answering. Arjun, can you tell me why? Arjun, are you here, beta? Arjun, are you there?
Yes.
Okay. So do you know why RHS would work, but a normal ASS will not work?
Why, sir?
So RHS is a property for congruency,
Yes.
but a normal ASS, which is an angle and a side, will not work for congruency.
Sir, because sir, RHS is right hand side, so there will be one side that has a 90-degree angle, but in ASS, so any angle could be congruent, but while the other angle could not be congruent. For example, like there might be a 70 degrees and another 70 degrees, but the other two angles might be 55 and 55 1 and 56 and 54 1. So it's not congruent.
But the sides are given to be equal here, right? This side is, so there is some other constraint, right? The side is given to be the same side. Akshar, I'll go inside your mouth if you yawn like this. Okay, all right. So Arjun, my question is, it's where these two are looking fairly identical, right? The only difference is this is 90 degree and this is 89 degree or 80 degree, whatever, right? Why will it work in one case but not work? What is so special about the 90 degree that it should work? Otherwise, both are logically the same thing. You have an angle and two sides which are not sandwiching that angle.
No.
You understand my question, Arjun?
Sir, I didn't get the question.
No, the question is, RHS property is also in a way like ASS. Agree with that?
Yes.
Okay. Why do you agree with that? Tell me.
Sir, because RHS is consists of one angle and the two sides congruent, and
Exactly.
ASS is also the same.
Exactly. And one side has a special name called hypotenuse. That's the only difference, right? So, but just what is so special that RHS works for congruency, but ASS does not?
So
Yeah,
RHS has a right hand, it has a 90 degrees angle.
True, but because of that, why? As a result of that, what happens is what I'm asking. Okay, Arsh, your hand is up. Yeah, go ahead.
Because of the Pythagorean theorem. So, like Pythagorean theorem, then the third side will also be equal, and then it'll become SSS congruency.
Exactly. Therefore, I can infer the third side. Prashant, your hand was up for some time. Is that also what you wanted to say? By Pythagoras. Okay, first let me just complete what Arsh said. So Arsh says, let's say this is given to be some side length A, then this is also A. Then if this is given to be equal to B, this is also given to be equal to B in measurements. Then automatically I'm inferring that this is square root of A square minus B square. And this is also square root of A square minus B square. Now, the three sides in one triangle match the three sides in the other triangle. Therefore, by SSS, I can say these two are congruent. Or even by SAS, I can say a side, angle, and side are equal.
Sir, either I find the fact that because of Pythagorean theorem, that's the main point. कि
Yeah.
Pythagorean theorem की वजह से वो Then
Exactly. Yes. Whereas in a normal ASS, let's say this length is given to be P and this length is given to be Q. This matches with P and this matches with Q. I cannot say that. In fact, you will see later there's something called cosine rule that you'll learn later. I cannot infer this third side and say that is the same third side here. Although diagrammatically this looks same, like looking at the diagram, but they need not be the same. Are you guys understanding? Arjun, does this make sense?
Yes.
Makes sense, right? Precious, that's exactly what you wanted to say, right?
yes, I mean, like, because of the Pythagorean theorem, they become equal. Yeah.
Correct. And therefore by SSS property. Okay. Now back to, so congruency, we saw all the different ways of congruency. Similarity. So if you prove two objects are congruent, then automatically they're similar, right? Because similarity means you only want the shape to be same. Size pay, you're not giving importance. If size also happens to be same, that's called congruency. Now, what conditions will work for similarity in addition to all of these properties that we saw for congruency? There's an angle. If three angles in a triangle match with three angles in another triangle, then these two triangles are similar. So a simple example would be, let's say I have a big triangle, right? And I have a small triangle, the exact same angle, right? The top angle is the same. Let's say this is also 80 and this is also 80. Okay, and this is also 70 and this is also 70. And this is whatever the balance is, 30, I think, right? 30 and 30. Then these two triangles are same shape. The angles are all same, but different size. Visually, we can see the different size. Therefore, by AAA property, these two triangles are similar. Not congruent, but similar. Now, as a result of similarity, what happens? There's something called scale factor. So this is, let's say this is ABC and this is DEF. Okay. Now, scale factor is, you can go either way. Either you can say, what is the ratio between a side here and a corresponding side there? So I can either say AB upon DE. For example, in this diagram, let's say AB upon DE is given to be, I don't know, 5, right? Which means the scale factor is 5. Or depending on which way you look at it, you can say the scale factor is 1/5, with smaller to bigger or bigger to smaller. Okay, so scale factor is, yes. Go ahead, Harsh.
Can you repeat?
The scale factor is the ratio of corresponding lengths in the two triangles. Okay, it can go either way, depending on the context of the question. It's the bigger to smaller or smaller to bigger. So it's either 5 or 1/5, one of the two. Now, the interesting thing is, Prashast, what do you think is the ratio of the areas of the two triangles? Right? Area of triangle ABC. When you put triangle like this, it means the area. Sometimes it means it's the triangle itself. Sometimes it means the area. Again, depending on the context, you can figure out. So suppose I ask you, what is the ratio of the two areas? Prashast, what do you think the ratio of the areas would be?
Yes. Oh, okay. Yes. So can you just repeat the question once?
So the two triangles are similar, and I'm saying the scale factor is 5 is to 1. What is the ratio of the two areas?
The scale factor is
5. Can you see the board?
Acha, so I'm just confirming scale factor is that like AB is 5 times that of DE.
Correct. AB is 5 times DE. Correct. And what is the ratio of the two areas? Okay.
So I think it will be 2.5 is to 1.
2.5 is to 1. Okay. All right. That's what Prashast says. Sorry, Akshar, your hand was up. Yeah.
I think it's 5 is to 1.
5 is to 1. Okay. So the answers so far are, okay. The answers are, okay. I'll just say answers here. Answers so far. I'm not saying what is right, what is wrong. I'm just listing out the answers. So one person is saying 2.5. One person is saying it'll be the same 5. Okay. Sukrit, your hand was also up. Sukrit.
I don't know. I thought I knew, but then I decided it's not the right answer.
Okay, but that's fine. Just call it out. Even though it might be wrong, it's fine. What was your intuition first? Why don't you leave the mic like this itself, and then you can use the mic mute button itself. Keep it that way, and then you have the mute button, right?
Yes.
Which you're also muting or unmuting. So that way you don't have to touch this part. It can always be like this. Okay. So what did you think the first answer was, Sukrit, that you have retracted anyway?
25.
25? 25 did you say, Sukrit?
Yes, sir.
Okay. Arjun, what about you?
Sir, I think it's 5.
You think it's 5? Okay. Any other answers? Vanya, any thoughts?
So I also thought 25.
Sir,
25.
Sir, 25.
25. Yeah, it is indeed 25. So the ratio of areas will be the square of the scale factor. Okay. So the reason that works is, okay, so these two triangles are similar. These two triangles are similar. Similar means what? Corresponding lengths will match exactly. Like I said, when you say a dad looks similar to his son, that means, let's say the face of the dad measures, I don't know, 12 inches. And the kid's face measures 3 inches. So 12-inch face, and then the kid's face is 3 inch. So this, let's say it's 12-inch, and the kid's face is 3 inch. And let's say you're looking at this guy's hand, and this kid's hand, right? So let's say this is, I don't know, 20 inches, then this will be the same 1/4. It also be 20 divided by 4, which is 5. Okay. But if you look at,
Sir?
yes.
Yeah, so I have a question. So why will it not be 2.5? Because ultimately, sir, okay,
I will tell you why it's 25 first.
Yes.
Okay. Arsh, your question?
Sir, I did it from another method. Like all the sides I took it as a ratio of 5. Like it will be 5 times of that.
Yeah.
And then you can do half of the base. So any value the same will be, it'll be half of the base, and then half of 25 into 5, which is 12.5, and 12.5 divided by 0.5, which is the other base ka ratio. Because like if we
half of base into height, did you say?
Like supposingly, let it be just be 1 and 1 in the smaller triangle, then its area will be 0.5, and then the other one will be
but I didn't say it's a right angle triangle. It's a 80, 70, 30.
Yes, sir, but the ratio will remain the same, right? So that
Exactly. So that's exactly the reason. So just to complete what he said, right? The ratio is 5:1, right? So for example, let's say this is let's say this length is P. Okay, maybe I'll just draw this diagram slightly bigger so that otherwise it's too small. Okay, so these two triangles are similar now. So I don't know, what did I call it? I called it PQR or whatever I called it, PQR. Okay, so let's say this is X. Then I'm saying this is 5X, although it does not look like that. I'm sorry, because I wanted to draw the smaller one a little bigger, which is why. Okay, and let's say this is Y. Then this is 5Y. And this is Z. Then this is 5Z. That's what similarity is. The corresponding sides will have the same ratio, right? Now, that holds not just for side length, it holds for any corresponding measurement. In particular, suppose I drop a perpendicular from A to here, and I drop a corresponding perpendicular from P to here. Okay, so let's say this works out to be H. Then this will work out to be 5 times H, because every corresponding measurement will be just like if the face is 4 times bigger for the dad, then the hand is also 4 times bigger for the dad. Same thing, right? Of course, I didn't draw it well, but you guys can get the idea. Therefore, what Arsh is telling is the height will also be the same ratio of 1:5, 5:1, whatever. And therefore, if you look at the area of this, it's half into 5X into 5H. Whereas if I look at the area of the smaller one, it's half into X into H. So the half cancels. The X and X cancel. The H and H cancel. So what remains is the 5/1 into 5/1, which is 25. So Sukrit, your initial intuition was right. Why did you have to say it is wrong? But what was your intuition? Was it similar? Yeah. I cannot hear you, Sukrit. Yeah, go ahead. Yeah. I can only hear the sir part. After that, I cannot. Yeah, go ahead. No, I cannot.
25
No. Okay, yeah, 25.
of those small squares could not fit in.
I cannot hear you well. It goes up and down. The voice goes up and down, Sukrit. Fix it later. So 25 of those cannot fit, you're saying.
Yes, sir.
Because I've not drawn it to scale. This looks like more like 1:2 rather than 1:5. So if I indeed drew this very small, like if I drew this, like literally 1/5 would look something like this, right? 1/5 of this would be this, and then this, and this. And I can fit 25 of them, actually, if I try. Does it make sense, Sukrit?
Sir,
Yes,
can I
sir.
keep my camera off? It's showing my internet connection is unstable.
Okay, but please, guys, for today it'll be okay. But you need to get strong internet connection, guys. Okay, and
Yes,
then
sir.
because I want all the videos to be on. Okay, so shall we move on? So ratio of areas is a scale factor square, and in fact, Prashant, does this make sense? Why it's 25 now?
Yes, sir,
Okay.
kind of. Sir, I didn't understand the last step that you did.
The last step is finding the ratio of the two areas. Half into 5x into h upon half into x into h.
Wait. So, I don't get it because, like,
So this
the
was
area
x.
of the big triangle
Yes.
is just the area of the big triangle is 5h into 5x into half.
Correct.
And then the area of the small triangle is half into x into h.
Correct. I'm just finding the ratio of the two. Half कट जाता है, x कट जाता है, h भी कट जाता है. क्या बचेगा? 5 and 5 and 1 and
Acha.
1.
Okay,
Makes sense.
got it.
Okay. And the interesting thing is we can extend this to 3 dimension. So just assume there are two very similar objects and the scale factor is 5:1. If you look at the volumes of those two objects, right? So one example is, let's say I have a small cone and a big cone.
So then it'll become 125.
Exactly. If the scale factor is 1:5, let's say, when this going from here to here, or let's say 1:4, because it's been too much of 5, right? Then the ratio of the volumes, this is the side lengths. For example, this radius is given, or this diameter is given to be 10 centimeters, and this diameter is given to be 40 centimeters, right? Two corresponding measurements determines the scale factor. Now, if I look at the wall, so this is diameter. And if I look at the two volumes, right? Let's say this volume works out to be V. Then this will work out to be 64 times V. Where is the 64 coming from? It's coming from 4 cubed. Whatever the scale factor is gets cubed. So you can fit 64 of these small cylinders within the big cylinder. At least volume wise, you can pour so much liquid. Okay, so area will be scale factor square, volume will be scale factor cube. Any linear dimension, meaning any length, right, will be, for example, if I ask, if I in this small cone, exactly halfway through the small cone, suppose I find what the perimeter of that is, and correspondingly halfway through the big cone, I find what the perimeter of this circle is. Those are all two corresponding same quantities, but they are lengths. Therefore, the ratio will be 1:4 in this case, because the scale factor is 4. Arsh, does it make sense? I mean, Arsh, you answered it, so you should be fine. All of you good, right? Manya, you with me?
Yes, sir.
Okay. Now, back to, in fact, all of this started because of the alternative method that Precious said, but I'm covering all of this because it's important what we come to next. So if I have two right angle triangles, okay, forget two right angle triangles, one right angle triangle. So let's say, let me draw a big right angle triangle. Sorry, I didn't want to draw. Okay, big right angle triangle. Okay, and I drop a perpendicular from here to here. Okay, now the observations that will come now will be very interesting, right? So first of all, this is 90 and this is also 90.
So
this
this diagonal is already given, or we have made it ourselves?
No, I made it myself. The perpendicular from the 90 degree to this. So this is, sorry. So let's say this is the right angle triangle ABC. And I'm from B, which is the 90 degree point, I'm dropping a perpendicular to D. Okay. Now, the observation is there are three triangles here, right? There's a big triangle, there's a small triangle, there's a medium triangle. The original big triangle. So the big, medium, and small. Okay. Now, all of these three triangles are similar to each other. Why is that? Because of the angle property. First of all, this has 90 degrees. So let's say this is 90-degree angle. So which is the 90-degree angle in the big one? In the big one, it's angle P. In the medium one, it's also angle D. In the small one is also angle D. Right? All of them are 90 degrees. And let's say I'm making up some angle. I'll just call this as, I don't want to necessarily give a number, but let's say it's 20 degrees, just for understanding. It need not be 20. So let's say, which is the 20-degree angle in the big one? It's A. If that is 20, then automatically this is 70. If this is 70, then this is automatically 20. And therefore, this is 70. Right? And therefore, all the three triangles have a 20, 70, 90. In this example, it need not be 20. It could be X and 90 minus X. In fact, let me just replace this with some instead of X and 90 minus X or something, right? Okay, so let's say I call this angle as X, then this will be 90 minus X, and this will be X, and this will be 90 minus X, right? So I'll replace this 20 also. So there's an angle of measurement X. Which is that angle, X degree?
So
Yeah.
how do we get angle B is 90 degree?
Angle B 90 degree is given in a right angle triangle I'm talking about. I'm starting off with the right angle triangle. I'm drawing a perpendicular from the right angle to the hypotenuse, that is BD. Yeah, Vanya?
The angle D is also given.
Yeah, I'm dropping a perpendicular from B to the hypotenuse. And therefore, BDA also becomes 90. That's my starting point. Yeah, Vanya? Vanya, you're also frozen. Understood, right, Vanya?
Sure.
Okay. I don't know why the internet is bad for multiple of you. Okay, so which is the X degree in the big triangle is angle A. In the medium triangle is what? The ABD triangle. It is also A, right? And in the small triangle, it's angle P. Right? Are you guys with me? Sukriti, you're with me?
Yes, sir.
Okay. And which is the 90 minus X degree? The 90 minus X degree in the big triangle is angle B. In the medium triangle, also it's angle, in the big triangle, it's not B. It is C. Okay. In the medium triangle, it's B. And in the small triangle, also it's C. So by AAA property, the three triangles are similar. Right? Do you guys agree? Because all of them have the three same angles. Therefore, the corresponding measurements will also be same. So let's list out which is the hypotenuse in the big triangle. The hypotenuse in the big triangle is AC. Okay. Which is the hypotenuse in the medium triangle? In the medium triangle, it's AB. And in the small triangle, which is the hypotenuse, it's BC. Okay. And let's say which is the medium side, and this is small side. These are all sides. The medium side in the big triangle is AB. Okay, are you guys all following? If you're not following, anyone please stop and ask. If I'm doing some mistake also, please stop. And in the medium side in the medium triangle is AD, and the medium side in the small triangle is BD. Likewise, the small side in the big triangle is BC. The small side in the medium triangle is BD. And the small side in the small triangle is CD. Right? So all of these will be proportional. Right? So if I do, for example, if I do AC upon AB, right? I'm comparing this and this. That'll be the same ratio as AB is to AD. And that'll also be the same ratio as BC is to BD.
BC is to BD.
Yeah? Understood? Yeah.
Yes.
Now, yeah, so this is an important concept. This is what Prashant applied in the very first question, right? Back to this original question. an alternative way to do this was using similarity of triangles. Let me just paste it again. That's easier.
So I honestly like that better because much fewer calculations.
Correct. Agreed.
Then
Yes. So similarity of triangles really helps in reducing calculations. Yes, I too like it. Okay. So like what did we do in similar triangles? So here, so this is A, let's say this is A and this is B and this is C. Okay. Exact same concept is getting applied here. So first let me draw the perpendicular from A to make a right angle triangle. So this is think of this as the original big right angle triangle. Now I might have labeled it differently in the previous one, right? So let's say this is D. Okay, and now I'm dropping a perpendicular from here to here. How do I know it's a perpendicular from D? Because only then it's a tangential, right? This is tangential, right? Whenever it's tangent, it's perpendicular to the radius. So you have this, you can see the same analogy here. So let's say this is my E. Okay, I have a big right angle triangle and I have a perpendicular drawn. So this is 90 degree and this is 90 degree. So the three triangles, you see the ADC triangle, this is the big one. And you see a medium triangle, which is ADE. And then you see a small triangle, which is CDE. All three are similar. Okay. Now we can therefore use the similarity property to measure the side length ratio. So what all do we know? We know this is 15. And we know this is 8. And we know that this entire stretch is 17. From where to where? From here to here. This entire stretch, 17. That we know. Okay. Now let's call this measurement as X. Okay, let's call this measurement as X. And this is 17 minus X. Okay, I'll write it like, okay, it's not ugly. I'll write it 17 minus X here, 17 minus X. Okay, the portion till AE is 17 minus X. So this is from here to here. Here to here is 17 minus X. And the X portion is from here to here. Okay, all of you so far with me in the diagram? Okay, now
Yes.
the two triangles are similar. Now let's apply the similar, all the three triangles are similar. Okay, so let's focus on the smallest triangle and the biggest triangle, right? In the biggest triangle, if I have to write in the big triangle, and if I write the sides in decreasing order, okay, the big triangle, the side lengths are 17 is the biggest one, uske baad 15, uske baad 8. Okay, I'll remove the sign here because it looks like, right? So 17 is to 15 is to 8 are the three side lengths. I'm not finding any ratio. I'm just saying 17. In fact, let me not even put ratio. Again, it's confusing, right? I'll just put comma bus, right? 17, 15, and 8. Now, if I look at the small triangle, if I look at the smallest triangle, the biggest length is the hypotenuse in the small triangle. So in the small triangle, the biggest length is the hypotenuse, which is 8. Okay. And uske baad R and uske baad X. Are you guys with me so far? Anyone, Akshar, you're with me?
Yes, sir.
Okay. Now, all we have to find is R, and it's very quick using ratios. So we're saying 17 upon 8 should match 15 upon R. Bas matter khatam. R, you just cross multiply. So 17R equal to 15 into 8. Therefore, it becomes 120 by 17. Very, very quick. Thanks for suggesting this, Prashast. But does this make sense, everyone? Panya, you're okay? All of you okay in this one? Arjun, you're okay?
Yes.
Sukrit?
Yes, sir.
Okay. Yeah, it might seem like we spent a lot of time, but this is extremely important. Similarity is important. Scale factor is important. How do you find areas, ratios using scale factor square? All of that is extremely important. Let me just think of a good question. Okay, fine. Something else will come up. We have done quite a bit on this right now. Okay, let's move on. Today I wanted to do a little bit of permutation combination. I think we started off last class, but I just wanted to continue further a little bit. Okay, so there are two things. One is choosing, and one is arranging. Okay, the two different problems. So choosing is what? Choosing is, okay.
Permutation.
No, choosing is not permutation.
Oh.
Choosing is something called combination. Maybe did I hear you wrong, or you said permutation first, right?
Yeah.
Okay. Yeah. Okay. And this is permutation, as you write. Okay. Yes. So this is called. They are all just fancy names. Huh? Literally, it's choosing and arranging. Just two simple things. Okay. Now, what do you mean choosing game? So, for example, let's say I have a basket of books. Okay. So let's say मेरे पास maths book है, science book है, history, geography, and English. I just want to have one couple more, right? And then with a different letter. Okay, fine. Biology.
Sir, I can't see anything you're drawing.
Why? Is it the same for others?
No, sir.
You can see, no?
Sir,
You can see it, right?
Sir, I
sir,
can see.
sir, I can't see anything, like blank screen. I can see your cursor, that's it.
Maybe something on your side, because all of these other guys are seeing. Let
Sir,
me
I can
just,
see.
let me
You
just
do
stop share and share again, if that helps.
Yes,
you
I can. Yes, now I can see.
All right. So I have all of these books lying around with me: maths, science, history, English, geography, biology, and let's say like one more, right? I want to make 7. Okay. So C for silk.
Okay.
Okay, fine. Jo bhi ho. Okay. So letters or books, whatever. Okay. And let's say you want to select 3 subjects from this 3 books, right? So in how many different ways can you select? Can you all think about it? Just forget about math. Just logically approach karo, jo bhi karna hai. Tell me, how many ways can I select 3 subjects? So my end goal is, I have my bag. I can only accommodate 3 books. I can put any 3 books. In how many different ways can I put them in my bag? For example, one example would be, I can take the geography book, the maths book, and the science book, let's say. That's one example.
So without repeating.
Obviously, they're all books, right? So, yeah, no repeating. I cannot take a math book and another math book. There's only one math book. But good question. Yes, I'm saying it's obvious. But maybe it's not so obvious, right? Yeah. So we have one book of each of these subjects. And I have to pack a bag of 3 books. Yes, Sukrit, tell me.
Sir, so the answer is 210.
210. Okay, all right. That's first answer.
Sir, I got 21, but I'm not sure. I'm just checking
21.
once.
So I've gotten either 14 or 28. I'm not sure. which one.
14, 28. Okay. So far, 4 different answers here. Anything else? Someone is chatting me. Who's that?
Oh, sir, I
Arsh.
to answer.
Oh, okay. All right. All right, Banya, anything from your side?
No, 1 second.
Yeah. No rush. Take 30
No,
seconds.
sir, it's not 21. It's not 21. So sorry. My bad. Not 21.
Okay. Fine. I'll erase 21.
So I'm getting 5040.
5040. Okay. Akshar, anything?
720. I'm getting 720. Sir.
720. Wonderful. It's good that we have multiple answers so to discuss.
Sir, I got 15. Sir, 15.
I even
15.
got 84.
15. 84. Wonderful, guys. Wonderful. Okay. Itne answers hai, jitne combinations nahi hai. Okay. That's good. And I'm very happy to say that none of these answers is right. Sab ke sab galat hai. That's fine. Okay. But we are here to learn. Okay. So, anyone feel, okay, sorry, maybe I should not have given that verdict. They are all wrong. Then now everyone will hesitate to explain. Okay. Let's go through how we, okay. Yes, Sukrit. Or sir, Arjun, yeah, go ahead.
Sir, if you select 3 subjects.
No, what was your answer? Tell me. If
Sir, 35.
35. Okay, all right. Okay, go ahead, please.
Sir, Sir, M, H, C, S, E, B, G. Sir, so there are 7.
Yeah.
So we need to select 3 subjects. So
Yeah.
it's 7C3.
7C3, but yeah, correct. But suppose you don't know what the 7C3 is. Okay, so if you knew it's 7C3, then yes, 35 is the right answer. Okay, that's wonderful. Okay, now
So you have to basically you have to choose 3 from 7. So it's 7C3.
correct. Now, wonderful, right? So let me just introduce the notation for everyone. Sukrit was the closest, even though in magnitude it was not the same. Yeah, by the way, this is Arjun's answer is right. Arjun. Sukrit answer was the closest in terms of small silly mistake he did, right? Or a silly mistake or a conceptual mistake, I don't know. What Sukrit would have done is he's thinking, his thought process is he can pick any one of the 7 books. Sukrit, you can agree or disagree with me after I say any one of the 7 books as the first one. Let's say he picked G, and then he picked any one of the remaining 6, and then any one of the remaining 5. That's what you did, Sukrit?
Yes, sir.
Yeah. But do you see a problem in this, Sukrit? Or anyone except Arjun?
Sir, yes, sir, I see it.
What is the problem, Sukrit?
Sir, so if you, let's say the first one you pick English and then
Yeah, in this
Chem.
example, it was G, M, and S. That was my
Yeah,
bad.
but then in what I said, you can even do MGS, so that's why it won't work.
Exactly. Yes. So
So it's basically you could double count it.
correct. Exactly. We are excess counting or double counting, because suppose you select M first and then S, then G, or whether you count S, you pick S first and then G, then M, or a few other things, S, M, and G. All of them, there are a few more, right? All of them are same actually, but we are counting them separately, aren't we?
So now I figured it out. So I figured it out now.
And
So,
therefore,
sir, after this,
and therefore, what should we do to compensate for it, Prashast?
yes. So basically, what we're doing is we have to remove 3 factorial, also known as 6 from the picture. Hata do bas, kyunki there are 3 different combinations for like the repeating, hai na?
No, not repeating, arranging them.
Yeah, arranging. Sorry. Then you take 3 factorial. Hata do 7 into 5, 35. That's the solution.
Hata do ka matlab means in this case divide by, right? So hata do could mean subtract also. We are not subtracting here, we are dividing, because all of those, there are a few more here, right? What is this number 6? Is the number of ways in which I can arrange M, S, and G, right? Let's say the ordering did matter. So M, S, and G, I could have called any one of them first, any one of them second, any one of them first, any one of the remaining 2 as the next one, and the last one, there was only one way. But all of them are exactly the same choice of books. Therefore, I divide by 6. Is this clear, Banya?
Yes, sir.
Okay. So this is what, how do you structure this? This is what Arjun is calling 7 choose 3. So in notation, sometimes people write it like this: 7, 3 within brackets. So this is saying out of 7 objects, in this case, it books in general, it can be anything, right? Out of 7 objects, I'm choosing 3 objects. So how do I? So it was 7 into 6 into 5 by 3 into 2 into 1. But a better, I wouldn't say better way, right? I can also write this as, for example, if I multiply both by 17 and divide by 17, the answer does not change, right? I can multiply and divide by any quantity without changing the answer. Now, why would I multiply and divide by 17? Doesn't make sense. But the point is I can multiply and divide by a same number without changing the value of that number, correct? So people figured out, let's multiply numerator and denominator by 4 factorial and 4 factorial here. What is 4 factorial means what? 4 factorial is 4 into 3 into 2 into 1. Any factor, all of you know factorial, right? Akshar, you're okay with factorial?
Yes, sir.
Okay. Okay. So why do I multiply by 4 factorial and divide by 4 factorial? That way, the numerator is 765 4321. So I can write it as short form as 7 factorial. And the denominator is 3 factorial and 4 factorial. So I can write it just in terms of factorials. So 7 factorial upon 3 factorial to 4 factorial. So tomorrow, let's say I have 100 books, of which I'll have to select 20 books. I don't have to write 100 into 99 into 98 all the way till 81. There'll be 20 numbers, by the way, not 80, 81. Upon 20 factorial. Instead of that, I can directly say 100 factorial upon 20 factorial times 80 factorial. By multiplying numerator and denominator by 80 factorial, the numerator becomes all the way till 100 to 1. Therefore, it's 100 factorial upon 20 factorial, 80 factorial. Is this clear to everyone?
Yes, sir.
Okay. So, in other words, if I have to generalize this, I can write it as n choose r. Of n objects, I'm choosing r objects. It's n factorial by r factorial times n minus r factorial. Okay. All right. Now, a small puzzle types. Okay. Let's say there are 100 students in class. 100 students in class. Okay. Which will have more number of, you don't have to numerically calculate, just intuitively answer. Okay. Team of 3. Okay. The school can select a team of 3 or it can select a team of 4. Right? Where will it have more number of options? Okay, so I'm not repeating. Let me repeat my question clearly. Right? There are 100 students in a class. Okay, the school team has to be a team of 3 or it has to be a team of 4. With a team of 3, we have how many ways can I select the team? It's 100 choose 3. With a team of 4, it's 100 choose 4. Correct? Which do you think is bigger numerically? Akshar.
So 100 choose 3.
100 choose 3 is bigger. Why?
Yes. So because 100 so because 100 times 99 times 98 is big upon 3 times 2 times 1 is bigger than 100 times 99 times 98 upon 4 times 4 times 4 times 3 times 2 times.
But the numerator is 100, 99, 98, 97. But 97 is not there here, no, on the left one.
Oh, yeah.
Okay. So this will be bigger, right? This is only 100, 99, 98 by 3, 2, 1. Okay. Or don't even think, just intuitively socho, right? So instead of team of 3, if it's just team of 1, how many ways can I select a team of 1? Only 100 ways, right? You have to select the top guy. It can be done only in 100 choose 1, which is 100. Whereas with team of 3, obviously more choices there. As the team becomes bigger and bigger, you have more choices, correct? More number of choices to more number of ways in which I can select a team of 4, more number of ways to select a team of 10, so on. Does it make sense? All of you with me? Okay. Sukrit. It might seem very obvious, but just to be very clear. So again, same class of 100. I can either select a team of 10 or I can select a team of 96. Which do you think is bigger?
Sir,
No, your voice is breaking up.
sir, the number of options,
Number of options, yes.
96.
Okay. Vanya, do you agree or disagree?
Agree.
Agree. And both of you are wrong. As the number of team size keeps increasing, after a certain point, it will start decreasing. Just think about it, right? How Vanya, you are the teacher. There are 100 students in your class. You have to select 96 students to represent the class. What would you do logically? Logically, what would you do, Vanya?
So there would only be one team. Like
Why are you unmuting? Yes. Go ahead.
there would only be like one team of 96, but in like team of 100 there would be 10. Oh, team of 10 there would be 10 teams.
No. I don't mean that way. There are 100 students in class, right?
Yes.
You have to select one team to represent the school. That team can be of size 10 or it can be of size 96.
So for 96 there would only be four options.
Why 4 options?
So because 100 minus 96 is 4. So 100 by 96 factorial into 4 factorial.
Yeah, that's different from 4 options. What he just said is 100 factorial by 96 factorial, 4 factorial. But forget all this factorial business. Just think logically. If you're as a teacher and she is not a math teacher, what will she do practically to select a team of 96? In class, there are 100 students sitting. Will she select you, and select count 96 people? Or what do you think logically she'll do? Yeah, Sukrit.
Sir, she'll take up 4 people.
Exactly. She'll say you, and you. All 4 of you are out. The rest of you are in. So in a way, she's selecting a team of 4, the team of worst 4. Right? And by her selecting a team of worst 4, she's automatically selecting a team of best 96. Right? And the choices for selecting 4 is less than the choices for selecting a team of 10. Right? So the number of ways of selecting 10 is more than number of ways of selecting 96.
Sir, so after 50, it will start decreasing.
Exactly. So in fact, 100 choose 4 will be exactly same as 100 choose 96. So selecting a team of best 4 is same as selecting a team of best 96, because choosing a best 96 is same as number of ways of choosing the worst 4. So the number of ways is still the same. And the formula also says the same, right? This would be 100 factorial by 4 factorial times 96 factorial. This would be 100 factorial by 96 factorial times 4 factorial. Which logically also makes sense. And also it makes sense. They are the same. Is everyone with me so far on this? Arsh, are you with me? Okay. All right. Akshar, one question. Okay. There are 16 people. Okay. In how many ways can I select? In how many ways can I select 0? I need to select 0 students. In how many ways can I do that? How many ways to select 0 students?
0 only, right?
0. Okay. Okay. Arsh, what do you think? You agree or disagree? He says 0.
Infinite.
Infinite. Okay. Okay. What are those infinite possibilities, Arsh?
So it could be anything.
Like what? There is any other answers? Arjun, how many ways to select 0 students?
So I think there's 16 ways.
Sir, there's
16
infinite ways.
I heard
There's
16.
0
Arjun,
ways. So there's no way you can't select it.
so which is 0 ways?
Yeah.
Okay. So I have 3 answers: 0, infinite, 16.
So I
0
think 16 raised to the power 16.
16 power 16. Okay.
Yeah.
All right. So 0, it's hard to describe, right? If someone says the 0 ways to select, I cannot ask him what is the 0, because he's saying there are 0 ways to select. Oh, kuch matlab nahi hai puchne mein, right? So maybe 0 is right. And the answer to the question is, if I ask, show me the 0 ways, I cannot show you because there's 0 ways. Okay. That could be the, whoever is saying 0, uska argument over rahega. But whoever said infinity, uska jawab dena padega. How is it infinity? You must choose many ways. Just to illustrate, aisa bhi ho sakta hai, aisa bhi ho sakta hai, aisa bhi ho sakta hai, and you should go to infinity. Which, Arsh, I think you disagree now. It's infinite. It's not infinity. Do you agree?
Yes, sir.
Okay. 16 kaise batao, Arsh? Or you went with 16 or someone else was 16? I forgot.
So I only did the last.
Okay. So among these two, which one is this?
So 16 raised by 16.
Okay, fine. Ye hata deta hu. Explain your 16 raised to 16.
So because like if I choose 16, then I'll have 16 more left to choose. So 16 into 16. Then
But what am I choosing? I have to select 0 students. Okay.
So it's like kind of, it
Okay.
could be anything.
Okay. Anything, Sukrit, what do you think?
Sir, I'm not sure.
Okay. What about
I think it will be 0 only.
0? Okay. Prashast, how many ways to select 0?
Yes.
Okay. All right. Okay. It's okay, guys. The answer is 1 way. Okay. Just, yeah. So these are the 16 students sitting. So this is just imagine the school has to select a team of 3 students, and those 3 students will go to some inter-school competition to represent the school. So here is the school bus, right? Suppose instead of 0 students, so the question was, it has to select 3 students. So what will that guy do? Let's say these kids are all labeled A, B, C, D, E, F, G, H, and all that, right? Okay. And let's say this select B, C, and X are the 3 best students, right? The school will select these 3 and send. Or in fact, let me not put it in alphabetical order, just so that people think B, X, and C. Just to say the ordering does not matter. These three are representing the school. This is the school bus. In the school bus, they'll go to the inter-schools competition. Okay, this is very clear. 16 choose 3. Sabko pata hai. 16 factorial by 3 factorial into 6 factorial, 6 into 13 factorial. You can work out the number, whatever that is. But suppose it's now not 3 students, but 0 students. Again, school bus is waiting. The school has to load up. This is the tire, not okay. This is the school bus with the tire. Okay, the school has to load up 0 students and send for the inter competitions. How many ways can it do it? Only one way. It has to send an empty school bus essentially. So there's only one way of selecting 0 from 16. The act of not selecting anything is one act. So in one way, I can select 0 out of 16. On the other hand, it will be very obvious if I select 16 students. How many ways can I select 16 students from 16 students? Only one way, right? That is obvious. You have to fill the entire bus with all the students. Exactly same thing, right? To select 0, it's like selecting all 16 and saying none of you are there, none of you are there, none of you are there. No, 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 no. Either sabko yes bolo, nahi to sabko no bolo. Both baat to ek hi na. Does it make sense, guys? Harsh, are you convinced?
Yes, sir.
Okay, so in other words, just to repeat, we agreed that n choose x is n choose n minus x. That we agreed, right? So example, we saw 100 choose 6, 100 choose 4 was 100 choose 96. And it's 100 choose 0 is also same as 100 choose 100. Or in this case, I said 16, right? So fine, let's keep 16. So 16 choose 0 is same as 16 choose 16. And both are 1. Okay, in one case, it's obvious. 16 choose 16 is very obvious. 16 choose 0 is not so obvious. But now we can think about it. Similarly, 16 choose 1 will be same as 16 choose 15. And both of them will be 16. You don't need any big math for this. 16 choose 1 means what? Out of 16, in how many ways can I select 1? 16. Either this guy or that girl or this guy or that girl or that girl or that guy. Right? 16 ways. And 16 choose 15, same thing. I scan through all my students and say, okay, this particular boy is bad. Remove him. Right? So if I have to choose 15, I have 16 ways of selecting the bad students. Bad student, I'm sorry. Okay. So and then this logic will hold good for any number. So 16. So 16 choose. Okay, 16 choose 3 will be same as 16 choose 13 and so on. And all of these numbers will be increasing, right? You have more choices, increasing. You have more choices to select 1 student, 2 students, 3 students, 4 students. And then the peak will happen at, as Sukrit was telling, right? At halfway point, that's when the peak will happen. 16 choose 8, exactly same as 16 choose 8. 8 in this case, because 8 is half of 16. But let's say it's 17, then 17 choose 8 will be same as 17 choose 9. And that's the peak. Both will be the maximum. Let's say there are 17 students. Selecting 8 students is same as selecting 9 students. Okay. All of you with me so far? Okay, cool. Now, arranging is very easy. So this choosing. Arranging is just factorial, right? So let's say already the choosing has already happened for you. The school has already selected the 3 students. What are the 3 students who won? B, X, and C. They're all going in the school bus to represent the school. Okay. And then let's say all of them won medals for the school. Okay. One guy got gold, one guy got silver, one guy got bronze. In how many different ways could they have got? That be just 3 factorial, right? For example, C could have got the gold, B could have got the silver, X could have got the bronze. It could have been in any one of them as gold, any one of them remaining 2, any one of the remaining 1. There's only one way. That's 6. So ways of arranging R objects is R factor. I have R objects. Arrange R objects. Okay, in our simple example, it was just 3 factorial. So there are only 2 concepts we need to know. What's happening, Precious? Kya khel rahe ho? Baith jao. Okay. All right. So Akshar is having fun because I'm scolding Prashad. I'm not scolding. I'm just saying focus either do. Okay. So please. TK, right? Arjun, meanwhile, happily went somewhere and he's come back. Okay, all good, Arjun? Okay, all right. So, arranging, so only two important concepts. Choosing concept bhi pata hai, arranging also pata hai abhi. Now it's a question of putting them together to answer any question. Okay, so let's start with a practical question, right? So let's say we have done these type of questions before. I think to the fag end of the last class, but let's do one more. Okay, so I have the digits 0, 1, 2, 3, so on till 9. Okay, so the question is how many 3-digit numbers can I select? Actually, not select. How many 3-digit numbers can I write down? Which are?
Just use the washroom once.
I'm making up the question as I'm going. How many 3-digit numbers can I write down which are multiples of 5? Okay, so I cannot repeat any digits. So just think of them as just like the 0, 1, 2, 3, so on till 9. Okay, so maybe a representation like this is good. So this is 0. So you have all these like Scrabble. You have all of these.
Sir, can I just use the washroom?
Yeah.
And can the numbers like which are there can be repeated?
No, that's what. It cannot be repeated because think of them as like small your pieces of a Monopoly game or something, right? You have their separate pieces. If I use 2, that's it. It's used up, right? So for example, I can lay out a number like 2, 7, 0. This is one example, right? This is a 3-digit number. Obviously, a number cannot start with 0. So it's a good example, right? I'll give a bad example also. So where I select a 3 here, 5 here, and 8 here, because obviously it's not a multiple of 5. Okay, and this is also bad. I cannot select a 0 here, even though it's a multiple of 5.
Can the numbers be repeated?
I already answered. Look at the few examples. Okay, numbers cannot be repeated. They're all individual. So this also I should mark it as wrong. Numbers cannot be repeated. Think of them as your coin pieces, and you're laying out 3 coins and making a 3-digit number like this.
And so can the starting be 0?
I've given an example to show that it's not possible.
Okay.
Can you see this?
Yes.
Okay, so to other question on repeats, I'll again give some other thing like this: 7, 8, or rather, I'll just say 5, 8, 5, because it is a multiple of 5, but still I'm not including it because digits cannot be repeated. So I've given a good example and 3 bad examples that will illustrate all the ways in which you can go wrong. Okay, Sukrit's hand was up. Okay, where are you, Sukrit? Oh, yeah, go ahead. Actually, chat your answer. I don't want you to. Actually, I'll give everyone 1 minute, and then I'll open it up for everyone. That way, all of you have thought through it. Arjun, you're thinking, or you finished? What? Which of the two?
Okay.
Yeah, go ahead, Arjun. Call it out.
Yes, so basically, the digits which end with 0 and the
No,
digits
what
which
is
end
your
with-
answer? We'll discuss later. Just tell me your
Oh,
answer.
my answer, just a second.
Sukrit, say hi to your dad. Sukrit's dad and I were office colleagues.
Sir, 180.
180. Okay, that's the first answer. I'm waiting to hear multiple answers.
Sir, actually just a second.
Okay.
So is it 144?
144. Okay. I'm listing out all the answers as you guys call out. And then
Yes,
we'll
sir,
discuss.
sir, even I think it's 144. 144.
Lot of support for 144. Okay. 30 seconds more.
Sir, I got
No,
180.
sir, not 144. Not 144. Sorry, not 144.
Okay. I'll erase 144. The other one. Okay. Yeah. Tell me, Sukrit, you said something.
180.
180. Okay. Anyway, I'm writing out the distinct answers called out so far. 180 is one answer. 144 is another answer. Shall we discuss? Or, yeah. Go ahead, Arjun. Arjun, you got 180, was it?
Yes. Sir.
Okay. Explain your 180, Arjun.
Sir, there's two ways of solving this.
Yes.
Sir, one is that you just directly do it with finding the number of terms. Like the largest three-digit multiple of 5 is 995, and the smallest is 100. So, according to the formula to find the number of terms, 995 minus 100 divided by the difference between the terms. So 995 minus 100, which is 895.
Okay.
Divided by
Before
five
you go
plus one.
further, would 995 be a valid number in this question that I've given you? Arjun.
Yes, sir. So you can't repeat digits.
Right?
So,
I told you this to illustrate, and I also said think of them as coins. You have to lay them out. Ek bar 9 use kiya, matlab they cannot use it once
okay,
more.
so then the answer will be 144. That's correct.
144. Okay. Arjun, go ahead and explain. Sorry, who got 144 as well?
Me.
Sir, I got 162. 162.
162.
176.
176. Okay. No, first I'm going with one. Who said 144?
Me.
Sir, 144.
Me.
Okay.
Akshay.
Arjun and Akshay. Okay. If you guys say me, I'm not able to sometimes look at
Akshay.
call out your name. That's easier, right? All of your voices look similar to me.
Akshay.
So okay, Akshay. Arjun, wait for a second, please. Let Akshay get his chance. Yeah, 144. Explain your 144, Akshay.
So there are two ways a number can be a multiple of 5.
Yeah.
Which is it has to either end with 5 or it has to either end with 0.
Okay, all right.
Yes, sir.
Yes.
Then we can try out the first two numbers. So the first possibility can be of 9. It can be any of 9, and then like any of the 9 numbers, and the second possibility could be any of the remaining 8 numbers. So 9 times 8 is 72, and then 5 and 0 both 72, so it becomes 144.
Okay, he's saying if I have 2 choices for the last digit, and then I have 9 choices for the first digit and 8 choices for the second digit. Therefore, 9 into 8 into 2 equal to 144. Okay, all right.
No,
Go ahead, Arsh. No, Arsh, go ahead.
So I did almost the same thing, but instead of 9 and 8, I chose 7 and 6 because 0 and 5 can't be repeated. So the number of into 2 possibilities will decrease. It becomes 7 to 6 into 2, which is equal to 7 into 6 into 2.
84.
I got 176 as an answer.
176. But I repeat your logic again once more.
So like he said 9 into 8 into 2. So I got the 2 as right, but it can't be 9 into 8 because we can't use that many times because no, I think it should be 8 into 7 into 2.
8 into 7 into 2. Okay.
112.
Explain your 8 into 7 into 2.
Because there are 10 digits, right?
Yeah.
So 0 and 5 can't be repeated. So it'll become 8. And then 8 was subtracted by 1, 7, 56,
Okay.
56 into 2.
But let me ask you one thing. Okay. Let me not ask you.
Sorry, I made a calculation error. It's actually 98.
98.
My bad. Calculation error.
Okay, all right. Before we discuss, I want to go in this order, right? Anyone saw a flaw in Arsh's description? Harsh is saying, okay, we
Yes.
agreed on why this was wrong, right? 9 into 8 into 7, 2, why it was wrong, did we agree? Or we did
Yes,
not
sir.
agree yet?
So we agreed
Because, what is the reason for that?
because 0 and 5 can't be repeated.
But he's not repeating 0 and 5. He's saying, he's not, in fact, his argument is, I can pick either 0 or 5 for the last digit. I have two choices. Having done that, I've exhausted only, in fact, that is the flaw in your Arsh, right? I've used up the
Yeah.
last digit to be either 0 or 5. The other digit is still there, right? So I have,
So,
I
sir,
still have,
sorry.
hold on one sec, Precious. So, Precious, you need to hold, please. Learn to hold. Okay, Harsh.
Yes, I got it. Then one number is increased because it can be either of the two.
Exactly, right? So if you fill the last digit, only one of the two digits gets used. The other digit is still in your kitty to use,
Yes.
right?
I
And
got
therefore, 9 into 8 into 2 seems right. But the flaw in 9 into 8 into 2 is what? Precious, can you tell me what is the flaw in 9 into 8 into 2?
Yes, sir. So, sir, it should be technically 8 into 8 into 2.
Why is it 8
मेरे
into 8
हिसाब
into
से
2? Yeah, go ahead.
sorry, yeah, 8 into 8 into 2, because number one, because of that 0 and 5, one of either 0 or 5 will come in the first digit. So 9 minus 1 is 8. So that's like the first part.
No,
Now
but
the
I don't understand why 8 has to. So you're starting off with the last digit being either 0 or 5. Now you come to the first digit. Why are you putting 8 again? Once more?
Yeah, because like the total choice
Yeah.
is like 9. Total, because you can't use 0 because then it won't be a 3-digit number.
Yeah, but then if the last digit happens to be 0, I can still use all of the 9 digits. The first digit can be 5 also, right?
No, I don't. Wait.
If the,
Wait,
if the last digit is 0, the first digit can be 5 or 6 or 8 or 1. It has 9 choices for the first digit. If the last digit is 5, then the first digit cannot be 0 and it cannot be 5. And therefore, this is where all of you guys have done a mistake. You have to treat them as two separate cases. Special. And I have to have two separate cases. A case, okay, this is case 1, case 2. Suppose a block 0, suppose a block 5. Suppose a block 0, let's do the first part. Then, like I said, I have 9 choices of selecting the first digit. I have 8 choices of selecting the second digit. Therefore, there are 72 numbers here. Suppose I pick 5 as the last digit in the right wala, then I can neither pick 0 nor pick 5 for this digit, right? And therefore, I have only 8 choices. And then now I've exhausted 2 numbers, the last digit and the very first digit. And therefore, I have 8 more. So this is 64. Therefore, the total
So
number
why
of
wouldn't
ways
this
is...
be 7?
No, because I've used only 2 numbers so far.
See, now you have used 3 numbers.
No,
We
not
used,
just
the first digit 0 and 5.
no.
Three
Okay, I'm saying the last digit has been used, which is 5. The first digit is some number other than 0 or 5.
It can
Right?
also be the number which you've used in the hundreds place. Like supposingly if you choose 7 in that hundreds place, then you can't choose 7. So that also possibilities are
Only 7 and 5 are now excluded, right? I cannot use 0, but 0 is back into the game now.
Oh, 0 is back into the...
Because it's the second digit, no?
Oh,
It's
yeah.
not the first digit.
Yeah.
Right? You understand the difference, Arsh?
Yes, sir. Yes, sir.
Okay. So in your example, you put, let's say, 3 as the first digit. Now, for the second digit, it cannot be 3 because 3 is used up. It cannot be 5 because that's used up. 5 is used up on the last digit. 3 is used up in the hundreds place. I have 8 digits now. Why? Because 0 is now back in the game. 0 was restricted in the first place, as in hundreds place. But now it's back in the game. And therefore, the total number of ways is 72 plus 64, which is 136. Is this clear, everyone? Oh, Precious, yeah, go ahead. Got a question?
No, sir, my hand was like left raised.
Oh, okay.
So I didn't get why can't we use 0 in the first place?
Because it won't be a 3-digit number, right? 025. I gave an example, right? It won't be a 3-digit number. Okay. All right, let's end the class here. I have to go for the next one also. Okay, chalo. See you. We'll continue. I'll send the recording.
Bye, sir. Thank you so